Now recording. Lovely. So, with respect to the midterms, there has been a change in policy with respect to the midterms at the top levels of management of the course. You will be receiving the midterms back. Previously, this was not going to be the case, but now, I guess, things have changed. We're going to give you the midterm back. I will go through it in class and give you a solution to the midterm in class. Still working on grading them. I've got about 10 left to grade the final question for. That bloody final question is taking me as long to grade as an entire assignment. Like, actually, it's terrible. So, I'm working on it. Next class, we will take up the midterm. So, we shall continue talking about databases. Is it just me, or is it a little hot in this room?
It's because the winter heating has now begun. And H has heated floors, so it's hot.
Interesting. The winter heating has begun, but the winter has not yet begun.
Yeah.
So
it's a little hot.
yeah. All right. Let's see here. What? No. So last time we were doing databases and web applications. I think we actually made up a lot of time by me just kind of skipping the SQL stuff that you're actually taking a course in right now, which I did do with the other class, so that I think we made up a fair amount of time there. So let's review connecting to a database, creating a database, all of that fun stuff. All right? So, first, let's talk about XAMPP. All right? Obviously, you will want to be testing your work on XAMPP for your further assignments which may involve databases. When executing, it's important to start both your Apache and MySQL servers. If you click the admin button in the XAMPP control panel, you are brought to PHP MyAdmin, which allows you to administer your database. A certain amount of this will be necessary, hopefully not too much. Right? This is where you create new databases, new tables, using schemas, all of that fun stuff. Right? So, let's see here. All right. When you're creating a new database in PHP MyAdmin, it is important that that database have the same name as the database that you already have on CS Unix. That way, you don't have to change the database name when you port your code for assignment. I think 4 is going to be the one that uses database stuff. When you port your assignment 4 code to CS Unix, if it's got the same name, then you don't have to modify that parameter. So, your database name should be the same as your CS Unix login name. In my case, that's MOORT. because I'm an instructor and we get named by last name instead of student number.
Good for you, sir. Must be nice being in the ivory tower.
It is nice having elevated privileges, I'm not gonna lie. So, we then create a table. The whole, the login credentials example will be useful once we start talking about security, database security, so let's go with that rather than something else that's simple. So, let's make a table called credentials. Number of columns 3. Go. I will have an ID number, which is a auto-incrementing primary key. There we go. Next, I want a username. Let's make that a varchar. How many characters should we have max for the username? 50? 15? 15 seems a little short. Let's make it 16. Always base 2. Always round to the nearest base 2. Yes?
I was just like agreeing with you, sir.
Yes.
That's why the level cap should be 128.
Yes, exactly. Varchar for password, make that 255, for reasons which I will explain in a bit. It has to do with security and stuff. So, good. In theory, you can apply a unique constraint to the username because no two people in the database should have the same username, right? But for the time being, let's just not worry too much about that and just go for it. There we go. So, last time, did I make the login page with the register and the run? No? Okay. Okay. Well, let's make ourselves a website. So if you go to Explorer, htdocs, well, I mean, you can do that. You should do that through VS Code, actually. VS Code is already launched. All right, there we go. Boom. Open folder. This PC, Windows, XAMPP, htdocs. Let's make a new folder. Databasing. Select. There we go. Now, if we go to localhost, will you just work? Advanced. Accept. Boom. That's localhost / databasing. And there's our default Apache thing when we don't have an index page. So, let's have two forms on an HTML page. One to register a new user, the other to log in with an existing user. Guess I trust myself. Perhaps I shouldn't. Ha, ha, ha. So, index.html. Throw in our boilerplate. H1, register new user. H1, log in with existing user. Sorry, what?
Can you zoom in a bit, please?
Oh, yeah, sorry. Probably much better for the people online as well. So, log in with existing user, register new user. We just want to make a couple of web forms for these two processes. Both web forms will just take a, they will only take a username and a password as inputs, right? And have a submit button. They're going to be almost identical to each other. The only difference is what PHP script they're targeting, right? Because we're going to have two different PHP scripts, one for registering users and another for logging in with existing users. Make sense? So far so good? Good. So let's bang out a form. Action register.php. Method. When we are sending login credentials via an HTTP packet, what method do we use? We use post. Why? Yes, it puts the credentials into the payload, which is point-to-point encrypted. The get parameters are not encrypted, and therefore your username and password combo will be visible to anybody intercepting the packet, including man-in-the-middle attacks. Yes?
Why would you use get instead of post them?
Because you make a mistake and it's the default. If you fail to specify a method, it'll go with get.
Okay, gotcha.
Yeah. And form. Input. Type is equal to text. Name is equal to new name. Sure. I'm just going to put a break in there because if there's one thing this class loves, it's breaks.
Can confirm.
So this is the second field is going to be a password. There is a password input type, right? It stars over the password that you're entering. But for the purposes of demonstration in this class, I'm going to leave this as a regular text field so that we can see what the password is that we're entering. Normally, you would select the password type. There. Make sense?
It's just like password.
Yeah, it's just password. I can show you the difference actually, since it's you know. Let me just throw the submit in here as well. So, there we go. Using the password input type, the password is starred out. So, that's a good one to use for passwords, but again, because I'm doing a teaching demonstration, I'm going to change that to a regular text field so that we can check the data that we're putting into the password field. Make sense? And it's less work than like setting up one of those little, you know, eyeball reveal hidden content thing, which is probably like a JavaScript widget or something.
I wonder how you do those.
Yeah. Oh, I'm sure Bootstrap has something for it or something.
Oh, yeah.
So, there we go. For logging in, literally just copy and paste the form, change the PHP script that's being targeted. Rather than register.php, let's do login.php. Look good? So far so good? Now, I'm going to create register.php, and I'm going to create login.php. And we'll just have those blank for now. Just so that we don't like get an error if we click submit, right? So far so good? So, viewing our web page. Wow, there we go. We now have two login forms. I suppose it would be useful to label these with labels to indicate which was the username, which is the password. This is not intended to be that. I don't care about the HTML, I care about the PHP. Yeah. So, any questions so far? So, let's talk about registering first, because without registration, there's nothing to log into, right? So, in our register.php script, obviously you want to start it off in the usual fashion. What's the first thing that we have to do? Yes, we are receiving our inputs from our post request. So, let's call this client username, client password. That is to say, username and password received from the client, right? Now we want to grab these in the usual way. I'm going to skip a little bit of the validation so that we can keep the example moving, but filter input underscore post. The parameter name that we are looking for is uname, and our filtering method will be filter sanitize. Now we have a couple of options here. You can actually, in the case of a username, it does make sense to exclude characters rather than substituting them for other characters, right? You want to be more restrictive about the characters you allow in a username, right? Generally speaking, you probably only want alphanumerics plus a select, more select number of special characters. So, in this case, I'm going to do sanitize email. Not because this is an email, but because the filter list for an email is reasonably restrictive. So, good. There's one. Filter. Here, let me fill this up. There we go. No. Filter input. Input post. Name is pass. Note, of course, the names given to the two form elements in the HTML. These are the names of the post parameters that we are pulling. This is filter sanitize. Let's just do special chars on that one. Although not supposed to use it, but well, it's crossing it out. We'll see. Let's do email twice. Good. Now, that's a bit more restrictive. That's a bit too restrictive for a password because it's going to filter out things like exclamation point and number sign and all a bunch of stuff that people typically use in passwords, but yeah, whatever. This is just for the purposes of demonstration. So now we have our input parameters. The next thing that we have to do is connect to the database. Here, we pull in our code from the slides. Remember that we are connecting to the database using the PDO the PHP data object interface. Did I talk about the PDO object interface yet? No? Okay. So PDO is a class which is provided without having to import any libraries in PHP. When you create a new PDO object, you send it all of the information that's necessary to connect to the database. This includes the URL of the database, what the name of the database is on the database server, and your login credentials for the database. So, let's talk about where the database is located first. So, it will often be the case out in industry that your database server is a separate machine from your web server, your Apache server, right? So, it is correct to think of the Apache server and the SQL database server as being separate servers that may reside on the same machine. The same way that using XAMPP, right here, right now I have two servers currently running on this guy, right? I have the Apache server and I have the MySQL server, and if I wished to launch them, I could also have the FileZilla, Mercury, and Tomcat servers running in parallel. Each one is used to service a different type of packet request. So MySQL is a separate packet type. So it's not an HTTP packet, right? It's a MySQL packet. That's a different packet type. Does that make sense so far? Not too bad, hopefully. So if the web server is attempting to contact an SQL server which is running on the same physical machine that the Apache server is running on, the web server accesses SQL the same way that our browser accesses the web server, through localhost. Does that make sense? So, you have your computer. You have a web server running on your computer. You have your SQL server running on your computer, and you can also have a client running on your computer. All of these things can run on your computer at the same time. When the client wishes to access the local web server, it's localhost. Right? When the web server wishes to access the SQL server, and it's residing on the same machine, that is also accessing localhost. Localhost is the name for all of the servers that are located in the same machine that the request originates in. Right? So, if your packet is not meant to leave the four walls of your computer, you are trying to access localhost. Does that make sense? So, this situation is the same
Sir,
on CS Unix.
would it be the same for like, multiplayer games when they ask for like a local game versus an online game?
So when a game is asking for a local game versus an online game, what it's typically talking about is LAN,
Yeah.
actually, rather than talking about like,
Play on the same machine. Like split screen. Okay.
yeah. Do you guys know the difference between LAN and WAN? Yeah, that's the difference it's talking about there.
Gotcha.
Does anybody not know the difference between LAN and WAN? Hopefully you all do. I don't know if they like teach that at some point in the program. Do they teach that?
Yeah, as a networking, fundamental.
That's
Beginning,
okay.
whatever.
Perfect. So, on CS Unix, while the client will be remote, off in some other direction, from the perspective of your PHP script, the PHP script is still running on the same machine that's hosting the SQL server. Therefore, from the perspective of the web server, the SQL server is still localhost, right? So, your PHP scripts that you write and upload to CS Unix will still be using localhost to access the SQL server. Because from the perspective of the PHP script, it is the localhost, right? Does that make sense? Hopefully this will make more sense as we do some examples. Good. So, in many ways, the process of connecting to a database resembles that of file interaction. First, you establish a connection, then you read data from that connection, and then you close the connection. So, database handle is equal to new PDO, PHP data object. We then have our string, which fortunately is much the same as it is here. Basically, it's the same as it is here, except you replace the capitalized things with a few things that are important. So please pay attention. MySQL host is equal to local host. There we go. Semicolon. DB name. That's the name of the database you're trying to connect to. So, in my case, DB name will be the name of the database I created, not the name of the table, the name of the database.
Like CO853.
Yes.
Yeah.
SA000, your student number. Yeah. The next two are your login credentials for the database. Now, your login credentials for the database will vary depending on where the database is. If it's on XAMPP, this is what your login credentials will be. Database username will be root, and your database password will be an empty string. That's the default for the MySQL servers on XAMPP. It's the same for everyone. On CS Unix, this will be your CS Unix username. On CS Unix, this defaults to SA underscore your date of birth, day, day, month, month, year, 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 year. The prof has the ability to reset these credentials. We can, at some point, we're going to log into CS Unix and see how things are working on there as well. But basically, on CS Unix, you can access this same PHP MyAdmin page by going to csunix.mohawkcollege.ca/PHP MyAdmin. You provide your credentials here, and it takes you to the same page that we have on Axam. Your view will be restricted to only the database that's been created for you. So you are not responsible for creating a database on CS Unix. You will be responsible for making a table or two. Make sense? In fact, your accounts have restricted permissions. You are not permitted to make databases. You only use the one that's assigned to you. Make sense? Cool. So don't screw them up too badly, eh? Good. So, let me just copy that in. There we go. So, database, username, database, password. Now, we haven't really talked about exceptions in PHP yet. They work quite similarly to how they work in Java. The PDO object throws an exception in the case when it can't connect to the database. So, we put that inside of a try block. Hope everyone was paying attention during Java. And then we catch, let me just sneak a peek at the syntax. Yep. Exception E, which I think might be the first declared data type I've seen in PHP so far. So, this is kind of an interesting one. Die. Does anybody want to guess what die does? It prints and also
Kills the program?
it kills the program. Yes. So
That's why it's called die.
that's why it's called die. Yes. Error. Couldn't connect. And then the the exception object will contain a error message, which you can then reflect back to the user. Get message. But the beauty of this little bit, if you can't connect to the database, it terminates the whole PHP script right there. So everything past this point, we can assume that the database was correctly connected to. So we don't have to put everything inside of a big if statement. right? Just keeps our tab level down. Good. So far, so good. Wonderful. So, just for the sake of interest, let's test things that far. If we manage a connection to the database, we should see a connected to the database message. There we go. So, register a new user. Username is Mr. Krabs 123. Password is money. And we have successfully connected to the database. There we go. So the next thing for us to do is to formulate an SQL query to send to the database. Now, given that you've been having an entire class on this shouldn't pose too much of an issue. Did everybody get that far? Does anybody need any help with anything? We good? Okay, good. I don't want to move too fast, you know? Don't want to leave people behind. Any more than is absolutely necessary anyway. So, we need a query. Using the PDO object, there is a very particular way of creating a query. Your initial inclination might be to do something like this. Query is equal to, then you make a string. For example, insert into credentials username, password, values, here I'll, there we go, values, client username, client password. This may be your initial attempt, right here, right? Looks good? Wrong! This is highly vulnerable to the SQL injection attack. We will be talking about SQL injection attacks later on, but basically, if you're not filtering well enough up here, the user, a malicious client might send you values here which constitute correctly formed SQL queries, which would then, you know, could be used to do lots of malicious things. But there's a very good reason we don't do things this way. All right? We don't do this way. The way that we do things using PEO where we want to insert data into the query, we leave a question mark. The question mark is a special character that will be replaced with the data we wish to insert in a safe way. Question?
Even if it's put in a string?
Yes,
Okay.
even though it's been put in a string. So basically, the next part is a command which scans the string, looking for these question mark characters, and then we can send parameters to the PDO object to fill up these two spots. So, next, we prepare the command. We use the database handle and use the prepare method. We then prepare our query for execution. In theory, you could just take this string and plop it directly in there if you want to, but I'm doing it this way, get used to it, basically. Next, we execute passing the parameters that we wish to pass. So, for example, success is command execute. We then provide a list of a list of all the parameters that we wish to enter in the order we wish them to be substituted in, right? So in this, we're going username, then password. So inside of our array, we must go client username, comma, client password. Doing it this way, the execute statement is sanitizing the inputs to make sure there's no SQL injection attack material inside of those parameters. In theory, this will also have been caught by filter input, but you know, multiple layers of security are better than one layer of security, right? Good. And also, it's also theoretically possible to store an XSS attack inside of a username. So there you go. So, the return result of the command method, or of the execute method, is a success code indicating whether or not the command was successfully executed, right? Now, this usually comes out as success, but one of the things that can fail here is if your SQL query is bad, right? If you have a malformed query, you're going to hit a failure state here. Now note, a failure to parse the query is different from getting nothing returned, right? It's totally possible, in fact, in a lot of cases desirable, that a database would return nothing as the result of a query. In that case, you would get success being true, but you'd still get no output, right? We're going to see how that can work. But anyway, for our purposes for the,
Quick question, the execute method returns a Boolean.
Yeah. Yeah, it returns a Boolean, did this query succeed? The actual data gets attached to the command object, right? The command object is the, so the prepare method returns an object as its result, right? So that's why command has a method, right? So command stores the data that we wanted to get out of the database. We can retrieve it later using a fetch command, or a fetch method. Make sense? Okay. We'll see how to do all of it. Don't worry. So, if success, echo user successfully registered. Otherwise, echo something went wrong, possibly your query is bad. So, saving that up. Oh, looks like you're complaining. Oh yeah. semicolon, gets me every time. Alright, so let's try this out. There we go. Let us attempt to register Mr. Krabs. User successfully registered. But don't take my word for it. If we go to the PHP MyAdmin view for our XAMPP server, go to Browse, you can see our database entry has been entered right here. User number 1, Mr. Krabs123, password is money. Very nice. So we have successfully added information to a database. So far so good? Does anybody need help with anything? Following along pretty well? Need a hand? Oops, sorry. Try clicking on credentials. Browse. Yeah. Seems to be incomplete. Did you save it?
That's a day to.
Let's do what? Refresh. There you go. Good. So far, so good. So, I'm just going to register a couple of additional users, just so we have something more than just one element in the database. So, let's make this Squidward. What should Squidward's password be?
I do not.
I hate all of you. I love it. There we go. And Patrick, what should Patrick's password be?
Rock.
Did you say password?
Yes, that's such a Patrick thing.
That is so good.
There we go. The other class said it should be his name.
No.
Patrick. That's a pretty good one too. And then SpongeBob. Password.
I feel like SpongeBob's password would be a paragraph.
So what happens if you put something in?
It's just that obsession.
Just to filter something.
Let me finish this one and then we'll do that.
Krabby Patty is the best version.
I thought maybe I'm ready.
Snails.
Oh, yeah, there we go. Garrett.
Aw.
Cute.
Yes, because that's so in character. Yeah. All right. So obviously now we've got our database a little bit more fleshed out. Boom. Now, let's see what happens if we try to register some unusual cases. How about empty username and password composed of all of the symbols? User successfully registered,
Oh.
but let's see what they registered. So,
So, if you leave username not able to know.
yeah, basically we're doing no additional validation on like what the reasonable things for a username and password to have should be, right? Ordinarily, a username should be longer than maybe 6 or 8 characters, right?
We can put a max of 16 on username.
Yes, we do have a max of 16
What if we
characters.
put in 17 characters?
It probably cut it off.
Yeah.
Let's see. A, B, C, D, E, F, G. successful.
So it just cuts it off, it's
Yeah, it just cuts it off. So, obviously, at this point, you know how you've been like drilled on data validation since like friggin' Python, you know? Like, they teach you how to use an if statement and say, this is used for data validation. Well, we're getting to the point where data validation is actually useful and necessary, right? So there are a number of different things that you should do to validate the credentials someone is trying to register to the user, to the database. Number one, the things should be over a certain length. Number two, there's probably a banned list of characters, right? Number three, you know those annoying things with passwords where you must use a letter, a character, a capital letter, a lowercase letter, a symbol, and the ashes of your dead grandmother, right?
What?
One of those types of things, this is the place to, well, see, the feedback that you would give on that would be done in JavaScript, right? Because you want dynamic feedback on whether or not the password is valid. You don't want them to have to reload the page to figure out if they're entering an invalid password, right? But, what do we never do with a client?
Trust them.
We never trust the client. Therefore, even if you implement validation checks on the client, you can't trust them, so you must re-implement the same validation checks on the server to make sure that somebody didn't bypass them. Make sense? So right now it's not a particularly good username password database, but it's okay for the demonstration purposes, Doing a fully featured user login system is outside the scope for this class. So, in general, user registration is now working appropriately. The thing that we now have to do is check a user login, right? Fortunately, much of this code can be duplicated. So, if you could please copy your entire register.php script over to login.php. Obviously, getting the post request, getting the post parameters will be exactly the same. Connecting to the database will be exactly the same. Where we start to have differences between the two is with the query.
So it's
Right.
not making it a database?
No, this is not creating a database. This is connecting to an existing database. If we hadn't done the step of going in through PHP MyAdmin and making the database before we attempted this, we would have had an error message because there's no database of that name to connect to, right? So the database it exists on a separate server outside of this PHP script. We are only connecting to an existing thing. We're not creating a database here. Make sense? Good. Any other questions? I feel like there's kind of like a general feeling of burnout in the room right now. Is that true?
Sir, I've been burnt out for
Since
2 months.
Yeah,
Like, that's just how it is.
yeah.
Yes.
Yeah, I sometimes wonder if like the term burnt out just means being an adult. So, yeah, if you're expecting some kind of magical time in your life when you're not burnt out, maybe you should like live 200 years ago, because in like northern Canada during the winter there's literally nothing to do, except try to not freeze to death and try to not die of scurvy. So,
Sir, they didn't really have much to do at all, ever.
Yeah.
Most of the people couldn't even read.
Well,
So
I
it's
mean,
like-
they had tried to scratch an existence off of the land, and that could take most of your time. But the problem is in winter, like,
Yeah, but
you
like,
got nothing to do.
no recreation whatsoever.
Well, that's the thing, you like, you have to make your own fun if you're like a, you know, a pioneer in the olden times in the middle of winter, like Winnipeg, you know? Anyway, so. So we're no longer interested in inserting values into our database. We are interested in retrieving values from our database. So the question then becomes, how do we check the credentials in our database? Right? In theory, we could just do a select star from credentials, right? Get the entire contents of the database. But if the database is large, you probably don't want to retrieve the entire contents, right? We start entering the same kind of idea as a division of labor between HTML, CSS, and JavaScript. We begin to understand that there is a division of labor between the database and the web server, right? What is the database good at? Any ideas? What's a database good at? What's it optimized for? Say again?
Storing data.
Storing data, yes, and?
Accessing data, like.
Yes,
Access like fast, so you don't have to.
precisely. Databases are optimized for storage and retrieval of data, right? So, there's a reason that the where clause exists in SQL, right? We almost never want to get the entire contents of a table and load it into PHP. It's a huge waste of RAM. What we want to do is we want to use the database's inbuilt algorithms to search the database for us, right? So, we want to load things a bit more restrictively. Select star from credentials where username is equal to the client's username, right? Now, in theory, if we had set the unique constraint, this would always return one entry from the database rather than all of the entries from the database. Keep in mind that if your database is located on a different machine from your web server, all of the data that you're requesting from your database also has to go through network, right? It has to go through the network infrastructure, and it constitutes network traffic, right? And you pay for network traffic. You don't pay for it if it's local, like local to a machine, but if it's using network infrastructure, it's costing you money. Yes?
I know we were talking about like index clustering last class. It said like insert faster than strings.
Mm-hmm.
Maybe like better to store it as like an ID or something. Is that, can you do that or no?
So the problem with that approach, right, is that how does the PHP know what number to use for the username without looking it up in the database? Right?
Yeah.
So you might as well just look up the username itself.
What if you're accessing multiple tables?
Well, oh yeah, if you're accessing multiple tables, but that's like, Right now, we're just trying to check login credentials. But yeah, if you're cross-referencing multiple tables, you're absolutely wanting to use the ID number.
Okay.
Yeah. So, you could do something like select password from credentials where username is equal to question mark. You could also do select ID from credentials where username is equal to the thing, supplied argument, and password is equal to the supplied argument. In this case, if the user credentials are correct and in the database, what do we retrieve? What's the result of that query going to look like if the credentials are good? Not yet. So this is a select query. Select queries return output, right, from the database. What does that query return if the username and password are located in the database? What's our output going to look like?
It's just ID.
Yeah, you will get just the ID number which has been returned from the database. What if the username and password do not match anything in the database? What do we get?
No.
We get null?
No.
False.
Error or something.
We get an empty data structure, right? So when you're working with the return results of select queries, we kind of have a bias towards associative arrays in this class over objects, but you can interpret rows in a table as either. But in either event, you'll end up with a big list full of rows. If that list is empty, then there were no rows retrieved, which means that you connected and executed the query, but that query turned up nothing in the database. This, if the database turns up just an empty data structure, this is what login failed looks like in our scenario. Does that make sense? Good. So, rather than talking about registration here, just for the sake of interest, I am going to change this to star so we see the whole entry. And let's see how we actually read our return result. So, this is the part where we actually retrieve information from the database. In our case, this is called command. We use command fetch. Command fetch. Now, we have a couple of options. As I said, database rows may be retrieved either as associative arrays or as objects. You specify which in the argument to the fetch method. So you can see we have PDO fetch fetch assoc for associative array, and fetch obj for object. You can also fetch both, which constructs a somewhat larger associative array that you can use both numeric indexing and you can index by the schema, by the table heading names, whatever they're called. You know what I'm talking about, right? The header, table header, yes. So let's fetch our Incidentally, does anybody remember what this operator is called in Hebrew? Does anybody remember what this operator is?
The double dots. Yes. Oh, yeah.
Any C++ programmers in the crowd? Yes?
Scope resolution operators.
Precisely so. It's the scope resolution operator. So,
Yeah, I'm not going
the fetch association tag has been stored inside of the PDO definition. You have to access it through the PDO object. The scope resolution operator tells us where to find that definition. Right? Make sense? It's another complicated way of not having to use dot. Good. Now let's just echo that data. Incidentally, I absolutely do not, well, let's JSON encode it first. Let's view what this data looks like. For anything resembling anything close to a production server, I absolutely do not recommend echoing retrievals from your credentials database directly to your client. Not a good idea, but we're going to do it anyway, just for the sake of demonstration. Question?
Before you run it, what is the full stop? Okay.
Oh, I'm sorry. Yeah.
Now?
There you go.
Okay,
Question?
I'm guessing we're gonna do an assignment on this?
Yeah.
Yeah.
I think
So,
it's going to be assignment 4.
yeah, so are we allowed to do the echo JSON encoded data straight to the thing?
I wouldn't recommend. I don't know if. Okay. It depends.
Okay.
I don't think that Steve's working on an assignment where you have to do a login system,
Okay.
but in general, like, the database should be considered sensitive information, right? Let's put it this way. If you're retrieving stuff from a database, highly unlikely that your end user knows what to do with a JSON, something that's JSON encoded. So that's going to be read by JavaScript probably, and then parsed out into something like, an Instagram post or something, right? Or a Twitter tweet, or something like that. So no, just viewing the raw data is something that we do as developers while we're testing and debugging. So it's just particularly with login credentials, you don't want to do that, right?
Yeah.
So if I'm logging in with an existing user, Mr. Krabs, 123, password is money. Submit. I'm connected to the database, and you can see I have retrieved ID 1, username Mr. Krabs, password money. I have retrieved my thing from the database. If, on the other hand, I mess it up somehow, so even more money, there's nothing to fetch, print says false, but it actually probably is a Boolean false, because a null would print as empty. So if the return result of fetch is false, that means you've either, like, there's either nothing to read in the first place, or you hit the end of what you need to read. Because, here's a question. What if we have multiple entries in the database? And I know I'm kind of stepping away from like the username password constraints, but what if we had multiple entries in the database with the same username? So username and password. So Mr. Krabs 123. Another thing we're not checking for right now is that, we're not checking for duplicates being added. In theory, you would use a unique constraint on the database, but as things are currently, we can add as many of an individual pair as we want, right? So, question is, if we then log in with that, right, we're going to get 2. We still just get the first one. The fetch command only retrieves 1 row at a time. We also have a fetch all command. So you've got 2 alternatives, and again, this should like feel a bit like the file I/O stuff, right? You can either do something like data is command fetch while data is not equal false, strictly not equaling false. We echo and update. So that's option number 1. There you can see we get both database entries echoed. The other alternative data is equal to command calls fetch all. You still have to provide the mode though. DDO fetch. So there we go. Nope. Array to string conversion. Oh, yeah. JSON code that. Yeah. So, we note the difference. Using fetch all, our rows are inside of an array, right? This array can be accessed, indexed numerically, right? Whereas if we use fetch, we are reading one associative array after the other until we run out of them. It's literally the same thing as the difference between fread and fgetS. Question? No? Okay. Yeah. Does that make sense? So, proceeding with our bad login check, let's now actually do the thing where we issue a session, we start a session based on whether or not the thing worked. So if we are starting a session, we can't echo anything before we start the session. Starting the session will be dependent on the return result containing one, probably one or more in this case, entries. Although I think let's just make it exactly one, and I will delete that bad entry from the database. Boink. By the way, being able to go in and delete data out of your database is probably a really good thing to know how to do for like jobs and work and assignments and such. Like that's an operation you'll need to do during debugging. Yes,
There's a delete button right there.
precisely. But if you can't get into my PHP MyAdmin, you know,
Gotcha.
yeah. Ooh, you can also just execute SQL queries directly from this. If you go to the SQL tab, you can, like, if you want to delete everything at once, you can do that as well. I'm not dropping the table. I like my table. Besides, okay. I will make a solemn promise to you. When I demonstrate SQL injection attacks to you, the last thing I'll do before we leave class, I'll drop the table. So, basically, we are looking to see if we're looking to see if one row was returned from our fetch command, from our query that we executed. We have all of our rows stored in data. How do we tell how many rows there are in that array? Starts with a C. Count. If count data is equal to 1, then echo login succeeded. Else echo bad credentials. So you could provide more specific information here, but normally you don't. It's a security thing these days that it's considered too much information to give out to tell a user that the username they're trying to access does exist, but that they've got the wrong password. That can be used to verify a list of usernames and partially extract information from your database. So, these days, if the username is good but the password is bad, we don't care. We just say bad credentials. Or we just say, login failure. Something sufficiently vague, right? You are soldiers in the information wars. Never give anybody anything they don't deserve. Principle of least privilege. You guys know the principle of least privilege? Have you heard that term? Okay. That's worth a brief digression. So, the principle of least privilege is an important principle in data security. The idea is you do not give any more permission to a person or a program than it needs to do its job. Right? So, for example, good example, none of you can see or have access to any other student database. Right? Your privileges have been restricted in that way. Why? There might be, I don't think that you could get into stealing code because it's just database and in theory all your database stuff will be given to you by us anyways. But, or maybe not, we'll see how it goes. But there's no reason for you to need any other student's database information, so you don't have it. Principle of least privilege. Yeah. I have a I have the ability to see student accounts, but my account lacks other forms of permission, you know. I'm pretty sure I can't delete student accounts, for instance. Like I have viewing privileges, but not like creation destruction privileges for student databases, I'm pretty sure. So, you know, at a certain point, there are some tasks which I can perform, like resetting your SQL database passwords. But there are other tasks which have to go above my head to the IT department who administers CS Unix, right? You have to go right to root administrators for some tasks. In theory, it's possible to ask them to completely destroy everything inside of your CS Unix account and give you a fresh one, for example. They can regenerate a CS Unix account reasonably easily, but I lack the privileges, right? So yeah, don't give out any more information than is necessary to accomplish the task. So, let us,
Sir,
you,
what if it's about like keeping someone who's having problems updated on when that problem will be fixed? Or how it's being fixed? Is that a thing of who's privileged?
it can be, yeah.
Why is that?
Well, let me see if I can spin up a scenario. Sometimes the type of concern someone raises is not, sometimes someone can like do something like raise a security concern, where the person who raised the security concern is not necessarily entitled to information about like what the exact nature of the breach was, right? This actually happened recently with me. There was a student who showed me a script that people were apparently using to install Steam on the lab computers. Some of you may be aware of this batch script that's been making the rounds. As a dutiful servant of the institution, I showed it to IT, and they were like, "Oh yeah, we'll have the cybersecurity team look at this." Turns out that particular batch script does nothing except like automatically close out of the user account control window for you. It just prevents the user account control window from popping up. It doesn't actually elevate any privileges. So it does that, in that case, it wasn't actually a breach of security. But if it had been, I wouldn't have expected them to tell me, like, you know, there are lots of things I wouldn't have expected them to tell me, right? Like, how bad it is, how long it's going to take them to fix it, you know, all of that kind of stuff. That's kind of, you know, I don't need to know that and probably shouldn't. Because if I were a blabbermouth like I'm being currently and told students about like how long it's going to take to fix some security breach that, you know, that I just described in class, because I'm talking about security breaches in class, you know, and if I, you know, do something especially stupid, like record my whole lecture and put it up on a public platform like YouTube, you know, could be a problem. Yes?
I don't know if you saw my reply to the email you sent me.
No?
Trying to do it without that,
Mm-hmm.
though, it actually doesn't let you even open the installer.
Mm.
For some reason, you have to use that batch script or it won't work.
Mm. Well, the thing I heard from IT is that in theory your accounts do have a level of privilege required to install Steam. So,
Yeah, I'm gonna call BS on that.
yeah. Yeah. Well, I don't know.
Except for that one time, for some reason, one of the times I opened VS Code, it had admin terms.
Oh.
and it let me like do a proper full install.
It's also possible that they're lying to me,
Oh,
right?
probably.
Yeah, because like, that's the other tactic in the information war is disinformation. It's possible that they would say, oh yeah, it was no big thing, and then in the background they're like, how do we kill this batch script that everybody's using, you know? Who knows? I don't know. I don't know anything about the internal workings, and I probably shouldn't, you know? All I have to do is, you know, dutifully do my work, keep my head down, and try to make it to retirement before the universe explodes. So,
That's one way to look at it.
so let's check to make sure that logging in actually logs in. So let's use a bad password first. Bad password. Submit. Bad credentials. Very nice. And if we use the correct password, login succeeded. Now, if you want to, you can do something like session start, right there. So once you have validated that the user has credentials, you can start a secure, you know, you can send them a session validation cookie. That way, you know, this is a login page, but we have nothing to log into. You know, like who knows what this actually connects to, right? But in general, that's where you would sort of insert. That's where you would start the whatever procedure was necessary to establish the secure session. Now that the credentials have been validated. Does that make sense? So far so good? Any questions? Okay. So, this topic kind of this example glides extremely well into the stuff that we're going to be talking about on Friday, which is how do we improve the security of something like this? Because right now, the security is kind of terrible. And I'm not talking about like the username and password checks that I said I was intentionally skipping, right? So storing our passwords in plain text anywhere is a bad idea, right? If anybody was to find their way into the SQL server and, you know, take a picture of all of your passwords, they would have, you know, they would have access to everything in, you know, they would have access to all those accounts, right? So this is another layer of defense against the SQL injection attack. Make your password stored on your database something that can't be used to log in, but can be used to verify someone else's credentials that they've entered, right? So, the process used is called hashing. Anybody hear of hashing before? Few people. So, for the remainder of the class, I'd like to do a 10-minute expose on what hashing is, how it can be used, and basically hashing for fun and profit. So, you will learn more about hashing when you do your data structures and algorithms course. I assume, because I haven't actually taken a look at the curriculum of that course, but I'm assuming hashing was in there somewhere. So,
I
Yeah, I would be very surprised if it wasn't. Hashing is like a super, super important algorithm. So, a hash can be thought of as a form of one-way encryption. So, how much do you folks know about encryption? Okay. Maybe, like, you know the general principles, you know. If you have, you know, a string, you encrypt, it becomes randomized characters, but it's not fully random. Like, it's random, the more random it is, the better the encryption is, but the trick with encryption is that it can be decrypted on the other side to retrieve your original information, right? This is the idea with encryption. Has anybody heard of the Caesar cipher? So, a sort of useful anecdote from history about encryption. One of the first instances of the use of encryption in history, you had the Romans, all right? The Roman legions, the military, right? They had messengers on a horseback that would run important military information up and down and right across all of the Roman Empire, right? That is an extremely vulnerable way to send information, right? All it takes is ambushing a messenger, taking his scroll, and you have all of that sensitive information, right? So, they started, I believe it was Julius Caesar, it could have been one of the other Caesars, but basically, Caesar developed the thing called the Caesar cipher. That is, you take a message, and you simply increase the letter, like you count 3 letters over, and you use that as a replacement letter in the message, right? So A's become B, C, D, right? E, F, G, H, right? Etc. You replace all, it's a replacement cipher. Yes?
Yeah, it was Julius.
It was Julius? Nice. Awesome guy, Julius Caesar, except for all the killing.
Yeah.
N-O-P, S-T, like, obviously they've been using the Latin alphabet, but, like, you get the idea, right? It's a replacement cipher.
Sir, S would be B.
Huh?
S would be B.
Yes, thank you. B, N, G, H, I, J. There we go. So even if you read Latin, right, that doesn't make any kind of sense whatsoever, unless you know what the trick is. And the trick is you just move the letters 3 letters back. You retrieve the original message, right? This is essentially the same principle. The only thing that's different with modern encryption is that the algorithm that we use to encrypt the information has become a lot more complicated, right? But yeah, so encryption invented by Julius Caesar. Hashing is a similar process. Password, hash, But there is no reverse hashing process. For mathematical reasons, there's no reverse hash. Once you have hashed something, it is impossible to retrieve the original string from it. So we think of hashing as being a destructive process. Now, what you can do, and this is how password hashing works. If you have A and you have B and you hash both of them, and they hash to the same string, we can be reasonably sure that they were the same password. Right? But we cannot reverse the hashing and compare A to an unhashed version of B, for example. That's not how the process works. Does that make sense? A lot of the time, the reason that hashing is non-reversible, and this is, hashing is used in applications like this, and hashing is used in a data structure called a hash table. In a hash table, you basically have a big array where each of the numeric indexes in the array, 0, 1, 2, 3, 4, 5, 6, 7, 8, for example, these are the hash values that you extract by hashing data into the table. So if I have, hoop might hash as 7, right? So then I can store hoop in my hash table at location 7, or some other information that's associated with hoop. So if you do that, so there are a number of tricky little things that you do to set up hash tables. Number one, you kind of always want one that's got a prime number as the number of slots. One of the easiest hashes is to simply take, a big number, 256, 267, there we go, and then just take the modulus of the size of the hash table, right? You want to do some, this is like a very basic one. You want to do some additional stuff on top of this, but only that much guarantees that this number will hash to one of those slots. Actually, it would be 8 plus 1. This is an extremely fast algorithm for data lookup. Basically, the amount of time it takes to find the data in a hash table is equal to the amount of time it takes to compute the hash and then one array access lookup, right? You might have a linked list hanging off of one of these things, but, in general, very, very efficient data structure for finding information. And it operates on the same principle. The only thing is, in password hashing, we are hashing to something like some kind of scrambled string for storage. In a hash table, you're hashing it into a set of numeric indexes so that you can look things up quickly. Does that make sense? Sort of? The hash the hash function itself, the more random its output, the better, so long as it stays inside of its bounds. And you are not really permitted to know how it operates in specific detail, because if you knew what the hash function was and how it was hashing, there would be no point in storing hashed passwords, right? Because you could just reverse the hashes. Well, you couldn't quite reverse them, but what you could do with a hash is reverse engineer a subset of passwords that hash to that password, or hash to that hash value, which is a much smaller set. So if you saw that hash in the database, you would be able to guess the username much more easily. But, you know, so the hash function itself is a secret, right? Make sense? Sort of? Well, class is over, so we'll try to make more sense of this on Friday. Yeah, let me just turn off my recording.